Welcome to the series of videos where we solve the questions in the 2026 WASSCE Elective Maths Paper 1. In this video, we solve questions 11 to 20. As usual, you can find more study materials on our website, preppyonline.org. Question 11. Given that 18 over y squared plus 1 over y is equal to 4, find the positive value of y. Or one way we can do this is we can try to eliminate the fractions, and we do that by multiplying through by y squared. So we have 18 over y squared plus 1 over y is equal to 4. If we were to multiply every term of the equation by y squared, then we would get 18 plus y squared times 1 over y is going to be y, and 4 times y squared is going to be equal to 4y squared. So here we have a quadratic, but we have to rearrange it to see, or to set it equal to 0. So we have 4y squared minus y minus 18 is equal to 0. So we want to factorize this quadratic expression. As usual, when you have a quadratic, there are a number of ways to do this. You're trying to break this term, let me underline that, and that term, you're trying to break them into their factors, and you're trying to find a way of combining those factors so that you get the coefficient of the number in the middle, in this case, minus 1. So you can say, well, let's say 2 and 9. We don't know where the minus should go. And let's say we want to break 4 into 2 and 2. Then we are trying to see, okay, is there a way to multiply these numbers by these numbers and add them so that we get minus 1? And we try that. 2 times 9 is 18. 2 times 2 is 4. The gap between 18 and 4 is too big. So that tells us that breaking this up into 2 and 9, or breaking this up into 2 and 2 is not the best. So we can try a different combination. If we try breaking 4 into 4 and 1, and breaking minus 18 into 2 and 9, what are we going to get? Well, if we combine 4 and 2, we get 8. If we combine 1 and 9, we get 9. So 8 and 9, the difference between them is 1. So we just need to attach the 9, so the minus to the 9, because if we do 4 times 2, we get 8. 1 times 9, we get 9, and 8 times 9 is minus 1. So that's a good combination. And then from that, we can write the quadratic factorization as this. If we say 4, so this here, 4 was matched to 2, and 1 was matched to minus 9. But when we are writing, we change the numbers, if you like, or we change the pairings. So the 4y term is going to go with the other one, not with the 2, but with the 9. So we're going to get 4y minus 9, and then we're going to get 1y is not going to go with the minus 9, but the other one, so plus 2. So this is the factorization. We can expand to be sure, and when you do that, you get 4y times y is 4y squared. 4y times 2 is 8y. Minus 9 times y is minus 9y. So that's how you get the minus y here. And then minus 9 times 2 is minus 18. So this is correct. All right, so when you solve this, what do you get? This one, y plus 2, if you set that equal to 0, you're going to get y equals minus 2. But we've been asked to find the positive value of y. So our solution must come from here. If you say 4y minus 9 is equal to 0, then y is going to be equal to 9 over 4. So that gives our answer as D. I mean, the method we use to factorize the quadratic, that's not the only way. So don't worry too much about it. If you have your own other ways of doing it, those are perfectly acceptable. Question 12. There are 6 passengers in a bus. In how many ways will 4 passengers alight, one after the other, at 4 different bus stops? So we have 6 passengers. Let's And then we have 4 bus stops. Let's draw one, two, three, 4. And we are trying to find the number of ways in which 4 passengers can alight one after the other. Now, here, the order in which they alight matters. So, if we were to call the passengers, let's call them passenger 1, 2, 3, 4. So, these are the names of the passengers, right? So, if they're going to alight at 4 different bus stops, let's say we have one ordering. In one of them, passenger 1 gets down first, then passenger 6 gets down second, passenger 2 gets down third, and passenger 3 gets down fourth. So this is one arrangement. You can have another arrangement, 1, 2, 3, 4. So here passenger 1 gets down first, 2 gets down second, 3 gets down third, and 4 gets down fourth. Yet another arrangement. So this 1, 2, 3, 4, if now we have 2, 1, 3, 4, that's a different arrangement, because in this one, passenger 2 got down first, or got down at the first bus stop, passenger 1 got down second, passenger 3 got down third, and then passenger 4 got down fourth. So even though you have the same guys getting down, because they got down in different orders, these two arrangements are different. So that's the kind of thing we're looking at. We care about the order in which people get down. So you can have 4, 3, 2, 1. This is a different order. All these three are different, even though they all involve the same passengers. So, how do we think about this? We can ask the question, well, at the first stop, now remember there are 6 passengers in the bus. So if you got to the first stop and you ask the question, who is going to get down? How many possibilities are there? And the answer is 6. Because if you have 6 passengers and you're asking that question, how many of them can, oh, yes, how many possibilities are there for who can get down? It can be any of the 6. All right, so that's for the first bus stop. Now, after that, when you get to the second bus stop, you no longer have 6 passengers. You only have 5 passengers left. So when you get to the second bus stop, you have 5 passengers left. And any of those 5 passengers can alight at the second bus stop. So that gives you 5 possibilities. And then now you no longer have 5, you have 4. So when you get to the third bus stop, the number of possibilities for how many or for who can get down is 4. And then after that, you no longer have 4, you have 3. So this is what's going on. At the first bus stop, there are 6 possibilities. And then for each of those 6 possibilities, once somebody gets down at the second bus stop, we only have 5 possibilities for who can get down. And then after those 2 steps, after this step and this step, when we get to the third bus stop, we only have 4 passengers left. So there are only 4 possibilities for who can get down. And then after the first 3 stops and people getting down, we are left with this one. So the number of ways in which 4 passengers can alight one after the other is going to be the product of these 4 numbers. So it's going to be 6 times 5 times 4 times 3. And what is that product? Well, 6 times 5 is 30, times 4 is 120, and 120 times 3 is 360. Now, there's a shorthand way of writing this, which is 6 permutation 4. That is, you have 6 items and you are picking 4 of them and trying to see how many permutations are there if you're only picking 4 of them. And this 6p4 is equal to 6 factorial over 6 minus 4, 6 minus 4 factorial. So this is going to be 6 factorial over 2 factorial. Now, 6 factorial is equal to 6 times 5 times 4 times 3 times 2 times 1, and 2 factorial is 2 times 1. So when you cancel out the 2 times 1, you're left with this quantity, 6543, which is what we had here. So if you understand what this expression means, 6 permutation 4, or in general NPR, then in this question you can quickly say that the answer is 6p4. But then it's more important to understand what the 6p4 really means, and that is the reasoning we went through, that you start with a certain number, and at the first stop any of those guys can get down. So those are the number of possibilities. And then once that one of them gets down, when you go to the next stop, you no longer have the initial number you started with. You have one less than that. And any of those can also get down, and so on and so forth until you get to the last stop. And then you multiply the number of possibilities together. Question 13. Find, in terms of pi, the area of the circle x squared plus y squared plus 4x minus 6y plus 3 equals 0. So we're given a circle and we're supposed to find the area. Well, one thing we'd like to know is the radius. If we could get the radius of the circle, then we could find the area using the formula for area, pi r squared. So we're going to try to find the radius. A number of ways of finding the radius. We could complete the square. If we were to complete the square, let's say we completed the square and we got something like this: x minus a squared plus y minus b squared is equal to something. Then whatever expression you get on the right, like this, is going to be the square of the radius. So that's one thing we could do, try to complete the square. We could also use a formula. There is, if you know that the general equation of a circle, if you write the general equation of a circle like this, plus 2gx plus 2fy plus c equals 0. If you write the general equation of a circle like this, then the radius is going to be the square root of g squared plus f squared minus c. So these are two ways of doing it. Let me recap. The first, you complete the square, and then the second, you write the general equation of a circle, you compare coefficients, and then you apply this formula. All right, so let's try to complete the square. We could try to use the formula, but let's try to complete the square and see what happens. So we have this. Let me write it again. X squared plus y squared plus 4x minus 6y plus 3 equals 0. All right, so we have, grouping the x terms, or the terms with x together, we have x squared plus 4x. Now, when completing the square, what we need to add to the x terms is half of the coefficient of x squared. So here, the coefficient of x is 4. Half of that is 2. So we add the square of 2. That's what's going to make this expression a perfect square. All right. Then we have y squared minus 6y. So here too, the coefficient of y is minus 6, and half of that is minus 3. So we add the square of minus 3. That's what's going to make this a perfect square. And then we equate that, we bring this constant term to the other side. Let me write it this way. So you carry it over. So we're going to have minus 3 on this side. Then we continue what we started. We're trying to make this a perfect square. So we've succeeded in doing that. This is equal to x plus 2 all squared. And then here too, we have y minus 3 all squared. And this is equal to minus 3. So here, I made a mistake. So here when I added the 2 squared to this term, to the terms in x, I should have added the same 2 squared here. So let me do that. And then here, when I added the square of minus 3, I should have done the same thing here. So minus 3 squared. All right, so here we have minus 3, then 2 squared is 4. So we have plus 4, and then we have plus the square of minus 3 is 9. All right, so we simplify this constant term. If you have minus 3 plus 4, that's 1 plus 9, that's 10. So we have this expression equal to 10. And if you remember what I said, that when we have x minus a squared plus y minus b all squared being equal to something, whatever you have on the right is the square of the radius. So now that we have something squared, x minus something squared, and we have y, or x plus something squared, we have y minus something squared equal to something on the right, it means that now r squared is equal to 10, or the square of the radius, the square of the radius is 10. So if you want to get the area, given that the formula for the area of a circle is pi r squared, if our r squared is 10, then our area is pi times 10, which is equal to 10 pi. So that makes our answer B. But again, we can use the second method I talked about, that is where we compare the equation of this circle to the general equation of a circle. So let's do that. We have x squared plus y squared plus 2gx plus 2fy plus c is equal to 0. So here, what is our 2g equal to? Our 2g is just the coefficient of x, is equal to 4. That implies that our g is equal to 2. What about our 2f? That's the coefficient of y. The coefficient of y is minus 6. So this implies that our f is minus 3. So, and then our c. Our c is the constant term, which is 3. So we come and apply our formula. We said that when you have these terms, g, f, and c, then the radius is the square root of g squared plus f squared minus c. And what is g squared? G squared is 2 squared, which is 4. So let me just write this. So 2 squared, and our f squared is minus 3 squared, and then our c is minus 3. All right, so we simplify this. 2 squared is 4, minus 3 squared is 9, and we have our minus 3. So this is what we are trying to find. 4 plus 9 is 13, minus 3 is 10. So our answer is the square root of 10. And that is the same thing we got. Here we got that r squared is equal to 10, which means that r is equal to the square root of 10. And here we've got that r is the square root of 10. So the two methods have given us the same solution. If you plug that in, you're going to get the same area for the circle. Question 14. Given that r minus 29x over 2x squared plus 3x minus 35 is equivalent to 5 over 2x minus 7 minus 17 over x plus 5, find the value of r. So here we have a mathematical identity. That's what this triple equals means. And what that means is that whatever you have on the left-hand side is always equal to whatever you have on the right-hand side, regardless of the number that you put in. So whatever value you choose for x, if you plug it into the left-hand side and you plug that value of x into the right-hand side, the values you get on both sides of the equation are the same. What this means is that we can choose values of x that make our simplification easier. And to start with, one thing we can do is we can multiply both sides by this denominator. If you realize that this denominator, 2x minus 7 times this x plus 5 is equal to that. So let's do the expansion just to confirm. So 2x minus 7, then we have x plus 5. If we multiply these together, what do we get? 2x times x, that's 2x squared. 2x times 5, that's 10x. We have minus x times 7, minus 7x. Minus 7 times 5, minus 35. So we simplify 2x squared plus 3x minus 35. So this is exactly what we have here. What that means is that these two expressions, or these two terms, 2x minus 7 and x plus 5, are the factors of this expression. So if we multiply both sides by this expression, then we can cancel out. So let's do that. We have r minus 29x, and this is over 2x squared plus 3x minus 35. This is logically equivalent to this 2x minus 7. Then we have this over x plus 5. We want to multiply both sides by this expression. So when we multiply the left-hand side by that expression, what do we get? We are simply left with r minus 29x, and then we still have this equivalence. If we multiply this whole expression by this quadratic, we're going to be left with 5 times the other one, which is x plus 5. And then when we multiply this one also by it, we're going to be left with 17 times the other one, which is 2x minus 7. So we have a new expression or a new equivalence on our hands. And the question is, can we choose a special value of x that makes our lives easier? And the answer is yes. For instance, if you look at this expression, 5 times x plus 5, if we were to choose x equals minus 5, this expression would become 0. And so this whole term will vanish. So let's make x equal minus 5. So if x is minus 5, so let's say set x to minus 5. When you do that, on the left hand side, you're going to get r minus 29 times our x is now 5. And this is going to be equivalent to, we said if you set x, sorry, we want x to be minus 5, not 5. So let me write that again. So we want x to be minus 5. All right. So this should also change. We should have r minus 29 times minus 5. And that is going to be equivalent to, when you set x to minus 5 here, you're going to have minus 5 plus 5. So this one is going to become 0. So we only are left with this one. And so this is going to be minus 17 into 2 times minus 5 minus 7. So we have r, then this minus 29 times 5. What does it give us? 29 times 5 is going to give us 145. And I should I should remove this equal sign. We are moving from here, so this implies this. All right, so r plus 145, this is that. So on this side we have minus 17, then 2 times minus 5 is minus 10. So minus 10 minus 7, that's going to be another minus 17. So we have r plus 145 equal to this quantity, minus 17 times minus 17. 17 times 17 is 289. So we have r plus 145 is equal to 289. So what does that give us? It gives us r is equal to 289. Let's write that. 289 minus 145. So we have 441. So that gives us r is equal to 144. So our answer is D. There are other ways of solving this. One of them is you can try to, instead of multiplying both sides by this, so that we now get this new equivalence that we got, you can do the substitution directly without doing that simplification. So let me explain a little bit what I mean by that. So let's create some space here. All right. What we're trying to say is that this equivalence, in fact, that's the key point about this question. Because this left-hand side is equivalent to this right-hand side, it means that any value of x you choose, it doesn't matter. Whatever value of x you choose, the left-hand side is going to be equal to the right-hand side. So you want to take advantage of that and choose values of x that are going to make your life easy. And for instance, let's say we set, so what we just did, we set x equal minus 5, but now let's set x equal to 0. The reason setting x equals 0 may be good is that there are a lot of terms with x here. This has x, this has x, this has x, this has x, this has x. So wherever you have x, x is just going to vanish if you set x is equal to, if you set x equal to 0. So let's see if setting x equal to 0 helps us. So we're going to get R minus 29. So here I'm going to write the 0. And then in the numerator, we're going to have 2 0 squared. So 2 0 squared plus 3 times 0 minus 35. Now this is equal to 5 over, we have 2 times 0 minus 7, then minus 17 over 0 plus 5. All right, so simplifying, we get R. 29 times 0 is 0, so that hasn't changed. Then here we have 2 times 0, 0, 3 times 0, 0, so we have minus 35. And this is equal to 5 over 2 times 0 is 0, so minus 7. And then here we have 17 over 0 plus 5, which is just 5. So here we can multiply both sides by 35 or minus 35. When we do that, we get R is equal to, when you multiply this by minus 35, you're going to be left with 5 times 5. If you multiply this by minus 35, you're going to be left with 17 times minus 7. So here we have 25. We have R is equal to 25 plus 17 times 7. Let's see what that gives us. We have 9, then 4. So we have 119. So we now try to add 119 to 25. And what does that give us? This gives us a 441. So this gives us what we got, 144 again. So that's the idea. Yes, we could also try to do some algebraic manipulation where we rewrite the right hand side, but that is not necessary in this problem because you have this magic symbol. Question 15. Consider the propositions X, Stephen is good at biology, and W, Stephen is good at health education. Write in symbolic form the statement Stephen is not good at both health education and biology. So we have Stephen is good at biology, that's X. And then we also have that he's good. So there's this end, he's good at health education and he's good at biology. So if we didn't have this not here, this is the expression I would have written. Stephen is good at both health education. So he's good at health education and he's good at biology. We can write this X and W or W and X. They are the same thing. All right, but now we have this not. And so what it means is we want the negation of this statement. So that makes our answer A. So here we are interpreting this statement to mean that it is not the case that Stephen is good at both biology and health education. Uh, Sometimes the way we use certain words in English, when you try to translate them into logic, it's not so clear what they mean. So you can imagine that in English, if you were to, or in ordinary, let me just say, in ordinary spoken English, if somebody were to tell you that Stephen is not good at both health education and biology, you may be, you, you may reasonably interpret that to mean that he's not good at either of them. So you're trying to say he's neither good at biology nor at health education. So he's not good at biology and he's not good at health education. You might reasonably interpret it to mean that. But here we are interpreting it to mean that it is not the case that he is good at both of the subjects. So we are taking this statement to mean that. And the reason for that is they could have said that if they wanted to say that he's not good at this and he's not good at that, they could have said that. But I can understand students who interpret the statement to mean this. Fortunately for such people, uh, we don't have this option directly, even though you could interpret this option D as that, because by applying De Morgan's law to it, you're going to get something like that. So, if you're a student who knows De Morgan's laws and you also have this problem with how to interpret this, because in ordinary spoken English, you could interpret this to mean that he's not good at health education and he's not good at biology. But I think what the examiners mean here is that it is not the case. So this is a better way to state these kinds of statements. You prefix whatever statement you have with it is not the case. So it is not the case, dot, dot, dot. If you want to say that you have a statement, so forget about the not in the statement, right? So in this statement, assume that this not is just completely not there. So the statement is Stephen is good at both health education and biology. If you want the negation of this statement, instead of using this not here like they did, it's better to say something like that. It's better to say it is not the case that Stephen is good at both health education and biology. Then you remove the ambiguity, because the positive statement or the statement without the not is this one. So if you now prefix it with it is not the case, then we are just taking the negation and then it's straightforward. But if you do it like it's been done here, where they just said Stephen is not good at both health education and biology, you run into the problem where some people may understand it this way, and it's not unreasonable. So that is how we speak, not just English. In many other languages, this kind of logical statement or this kind of statement can be interpreted in different ways. Question 16. If log to the base 2 of x is equal to 2/3 and log to the base 2 of y is equal to 3/2, or 3/2, find the value of log to the base 2 of this. So here we are being invited to apply the rules of logarithms. If we write log to the base 2 of square root of y to the 4th over x to the 3rd, we can write this in another way. The square root of any number, square root of a is equal to a to the power half. So if we write that, then this is equal to log to the base 2 of y to the 4th over x cubed, this whole thing to the power half. And one of the rules of logs is that if you have log of a to some power to the power n, this is equal to n times log of a. So here, this to the power half that we have is going to come here. So what do we have? We have that this is equal to half times log to the base 2 of y to the 4th over x cubed. All right. We also have this rule of logs. If you have log of A over B is the same as log of A minus log of B. So what it means is that we have this half, this log of y to the fourth, it becomes this minus log of x to the third. All right. And then we continue our simplification. We used this rule before, this rule that says that log of a to the n is n times log a. So we use that rule again. This 4 comes here. So we have 4 log y minus 3 log x. So I just realized that I had been leaving out the 2, but we are working in log to the base 2, so that's not a problem. All right, so here we can try to do substitutions. Let's do that. So we come here, we say half 4 times log to the base 2 of y is 3 over 2. And then we have times minus 3 times log to the base 2 of x, which is 2/3. So this is the expression we have, and it's equal to half times 4 times 3 over 2 is equal to 2 times 3, which is 6. And then we have 3 times 2 over 3, that is 2. So we have half of 6 minus 2, which is 4. Half of 4 is 2. So our answer is B. Question 17. If the domain of f such that x goes to 1 over 2 plus x is that, find the range. So you have a function, you have its domain, the numbers we are given, and each number is going to be mapped to something. That's the kind of idea we're dealing with. So we're just going to substitute the values. If you have that, we can write this as f of x is equal to 1 over 2 plus x. So you put in the individual values. Let me say, let's say value of x, and then value of f, right? All right. Or let me just say x. So on the left, we just have x, and then on the right, we have f of x. So when x is 1, what's going to happen? We put 1 in this, so you're going to have 1 over 2 plus 1, which is equal to 1 over 3. So that's what we get here. When x is 2, we get 1 over 2 plus 2, which is 1 over 4. When x is 3, we get 1 over 5. When x is 4, we get 1 over 6. When x is 5, we get 1 over 7. So these are the values we're getting. So if this is the domain, right? If this is the domain of the function, then this is the range. So if the domain is this set 1, 2, 3, 4, 5, then the range is also the set 1 over 3, 1 over 4, 1 over 5, 1 over 6, 1 over 7. But looking at the options, we don't really have this range here. What we have rather is an interval in which we can find this range. So if you arrange these numbers in ascending order, so that 1 over 7, which is the smallest, comes first, then you can write your range this way. So 1 over 7, 1 over 6, 1 over 5, 1 over 4, 1 over 3. But then again, uh, you might be tempted to say that this is the range, because every number here is in that interval. Um, every number in this range that we found is between 1 over 7 and 1 over 3. But the problem is that this interval contains numbers that are not in the range. In other words, if you're looking for numbers in the range here, or numbers in the interval, this interval, let's say you draw a number line and you have 1 over 7 here, and then you have 1 over 3 here. Let's do this, 1 over 3. Then the question is, are you saying that every number that is between 1 over 7 and 1 over 3 is in the range? Well, take a number like 2 over 7. So 2 over 7, let's say 2 over 7 is somewhere here. If you claim that the answer is B, then a number like 2 over 7, which satisfies this interval or is in this interval, must be in the range. But if you say this number, 2 over 7, is in the range, then the question is, what value of x? Remember that we started by saying that this is the domain. The domain is a finite domain, 1, 2, 3, 4, 5. So which of the 1, 2, 3, 4, 5 we have here is going to give you this 2 over 7? And the answer is, there is no number in this list that's going to give you 2 over 7. That is why, even though B seems close to the result, B cannot be the answer, because B contains numbers or values that we have no value of x that will take us there. So we have, let me recap, we have the domain, and then you have the range. And every value in the domain is being mapped to something in the range. And by substituting all these values they've given us, 1, 2, 3, 4, 5, into the function, we've got the full set over here of values that we can get, x and f of x, for every one of the values that they've given us. But then the answer is not, there's no answer here that matches the range that we found. And I'm trying to explain the problem. The easy answer here is to say that there's no answer. None of A, B, C, D satisfies this range that we found. But I'm also aware that you can be tempted to choose B. And I guess if you wanted to choose something, B might be the best option to choose right now. But I want to explain why B is not correct. And B is not correct because this range is an interval. An interval like you have on the number line that says that the range is every number between 1 over 7 and 1 over 3. But I just gave an example of a number, 2 over 7. 2 over 7 is in that interval, and yet no number in the domain is going to take you to 2 over 7. So that cannot possibly be the range. So in this case, I guess uh, the examiners may have to give everybody a bonus point or something like that uh, to address this issue. Question 18. Given that P equals 3i minus 7j and Q equals 4i minus 9j and R equals minus 2i plus 5j, find the length or the modulus of 3p minus 2q plus r. So here we start by finding this vector. So here, because they are vectors, we may want to write them so that it's clear that they are vectors, but I'm not going to do that. I'm just going to do that here. I'll do that again. So we normally underline so that you know that these are not ordinary letters. They represent vectors. All right. So 3p is going to be 3 times. We have 3i minus 7j. I'm not going to underline these ones. Uh, minus 2q. So minus 2q is 4i minus 9j. And we have minus 9. Sorry, we have plus r. So what is r? R is minus 2i plus 5j. All right, so let's see. We can try to put all the i's together and also put all the j's together. Here we're getting 3 times 3i, that's 9i. We we get from here minus 2 times 4i, that's minus 8i. And then here we get minus 2i. So this puts the i's together. And then let's put the j's together. We have 3 times minus 7, so minus 21. Sorry, minus 21 j. Then we have minus 2 times minus 9, that's plus 18 j. And then we have plus 5j. All right, so simplifying for the i's, we get 9 minus that. So this simplifies to give minus I. Then for the j's, what do we get? We have 18 plus 5 is 23 minus 21 is 2. So we have plus 2j. All right, so this whole expression has given us that. And now we are trying to find the length of this. So minus 2p plus r. That is the length of this vector. So the vector is minus I plus 2j. And you find the length of a vector by squaring and taking the square root. So you square the coefficients, minus 1 squared plus 2 squared, all under the square root. And what does this give us? 1 squared is just 1, 2 squared is 4. So this is equal to the square root of 5. That's going to be the length. So you can punch this into your calculator and you'll find that it's equal to D. Question 19. Which of the following matrices does not have an inverse? So a number of ways to think about this. For a matrix to have an inverse, it means that if you think of a matrix as performing a linear transformation, then it's taking values from one set into another set. And for it to have an inverse, there has to be a way of going back. So if you move from here to here, you should be able to come back. And that's what the idea of an inverse is. So if you use that idea, you're going to come, you're going to look at this problem in one way. Another way, which is the way many students will do it, is to find the determinant. So if the determinant of a matrix, let's call it M, if the determinant of a matrix is 0, then that matrix cannot have an inverse. And the reason for that is that if the determinant is 0, then that matrix is taking some values from, if you like, the domain to the codomain, is taking multiple values from here to the same value here. And so once you get here, you don't know how to get back. That's really what's going on with this condition. So we can try to find the determinants of each of these matrices and see which of them gives us a determinant of 0. If the determinant is 0, then there is no inverse. So let's do that. The determinant of a matrix like this is AD minus BC. So let's find the determinant of this matrix. It's going to be 0 times 0, which is 0, minus 1 times 1, which is 1. So the determinant is minus 1 here. Here is 1 times 0, 0. 1 times 0, 0. So here the determinant is 0. So we've already found our answer. But let's continue. So here we have 1 times 1 minus 0 times 0. So the determinant is 1. And then here we have 1 times 1, which is 1, minus 0 times 1, which is 0. So here. So this is the matrix that has a determinant of 0. So by that condition, that when the determinant is 0, there's no inverse, this matrix does not have an inverse. But going back to what I was trying to explain, if you think of this matrix, this 1 1 0 0, let's look at a vector like this vector. So a vector like this vector, when you multiply this vector, this matrix, by this vector, what do you get? You get 0 0. Okay, what if you multiply this vector? Let's say any vector like this, right? So 0 2. So you want to multiply this matrix by this vector. What do you get? You get 0 0. So immediately you begin to see what the problem is. You have a matrix and you multiplied it by this vector 0 1, and you got 0 0. You multiply that same matrix by a different vector and you got 0 0 again. So the question is, if you had an inverse, or if you're looking for an inverse, that inverse has to now move you. So this matrix, it moved this vector to this vector. It also moved this vector to this vector. But what an inverse does is to move you in the opposite direction. So now after getting 0 0, how do you go back to this? And here too, after getting 0 0, how do you go back to this? The problem is that two different vectors are giving us the same value. And so once you end up in the codomain, you have no way of going back because there are so many ways of getting 0, 0 in the codomain that you don't have a unique way of coming back into the domain. That's the problem with this matrix, and that's why it doesn't have an inverse. Question 20. Factorize this expression: 8p cubed minus 27. This is a difference of cubes. If you have a cube, a number cube minus another, then there's the famous SOAP method of factorizing. And the SOAP method, well, it's not a SOAP method, it's just a mnemonic for remembering the formula or what to do. So this is the same as this: a squared plus ab plus b squared. So this a cubed minus b cubed. So this is a formula. In fact, it's an identity that you have to memorize because it's going to make your life easier. Whenever you have a difference of cubes like this is how to factorize it. And in fact, if you have a sum of cubes also, a sum of cubes also follows this. So let me put that here. So blue for negative and red for positive. So when it's negative, this is what we have. And then we have here like this. So notice that here we have plus or minus here. And then here we have minus or plus. So that's where the SOAP idea comes from. SOAP means same, opposite, and then always positive. Always positive. So this is saying that the sign here is the same as the sign here. So let me use an arrow to represent it. You have a sign here, whether positive or negative, plus or minus. Whatever the sign is here, that's going to be the sign here. And you're going to have the opposite sign. So if you have positive, you're going to have negative here. If you have positive here, you'll have positive here. Because of same, you have negative here. But this one is always positive. Whether it's positive or negative on this side, this is always positive. And then if you have negative here, you're going to have negative here, but you're going to have positive here, and you have positive. So same, opposite, always positive. That's a SOAP method for remembering this formula. So from this formula, let me just write it again because I've written so many other things on the side. So this is going to give us this. Then we have a squared plus ab plus b squared. So here, what we are cubing is 2p. If you cube 2p, you're going to get 8p cubed. And here, what we're cubing is 3. If you cube 3, you get 27. So using this formula, it's like our a is 2p and our b is 3. So if we substitute those values here, we're going to get 2p minus 3. And then here we're going to get 2p all squared. Here we're going to get 2p times 3. And here we're going to get, let me clean this up. What are we going to get? We're going to get b squared, which is 3. 3 squared. Okay, so this is equal to 2p minus 3. Then 2p squared, or 2p all squared, is 4p squared. 2p times 3 is 6p. And then 3 squared is 9. So looking at the answer options, the answer is A. That brings us to the end of this video. As usual, you can find more material for practice and revision on our website, preppyonline.org.